Good afternoon, students. Today we have sixth lecture on medical informatics and biostatistics. And first of all, I want to complete part about types of information system and some specific solution for being used in healthcare. And then I will try to speak about some practical approach related to development of major core of information system or database. So first of all, let's start with the second part of topic from previous lecture, which is about classification and usage of medical information, medical related information system. But before we will consider types and classification of at least few types of medical related information system, it's have to be important to at least define terms what is electronic medical records, because all further systems rely to some specific implementation of EMR for some specific particular purpose. So in general, if we talk about meanings of what is medical records and how it was look like through years, hundreds of years. So medical health, medical chart is systematic documentation of patient medical history in care. And it's used for represented like physical folder which contain, but is also entire of information, body of information which comprise total each patient health history. For years, hundreds of years, medical records have been written on paper, divided in useful second, housed in clinical sites or in doctors' offices, and as well. And what is important to remember, and every time that's medical records legal documents and are subject of laws and country states in which they are produced. So major of turning and creating electronic medical records, it's converting that's deprecated paper form representation and keep information every time online, keep accessible in seconds on the fingertips and so on. So move from left to right, and even later I show another version. And multiply reason do we have when we move from paper representation into digital representation, like we can access data in seconds, we can waste valuable time for looking for a chart, we can be ensured that it could be secured for sure if whole information system in physician office or hospital will be secured properly. Also, we have share information with multiple physicians at a time, and we have ability for collaborative, simultaneous work and so on. So actually multiply, and here is listed other extra benefits like billing, access for billing, chatting, reporting, and so on. So list of potential benefits of usage of and option electronic medical records provided and supported by particular information systems. It's very broad. It's important to remember that despite more often it's used the term electronic medical records, there is at least 3 different kinds of these records. So conventional EMR or electronic health related information on individual within one healthcare organization, so particular hospital or physician's office, which create new records about specific patient only visited it. It will be created, means that new one electronic medical records created. With ability to exchange information between various facilities and integration of records from another facilities, medical healthcare facilities, we can talk about introduction of electronic health record. So it's electronic health record information on individual across more than one healthcare organization. So we aggregate, summarize data from multiple facilities. And once we grant access for patient for this data or any part of it, so that part which patient could access it covered personal health record. So it's information shared and controlled, managed by an individual. So here is we have three key backgrounds, like three key kind of electronic medical records. Electronic medical records per facility, aggregated EHR, and managed by patient, it will be personal health records. So main features, that's all these three are stored in digital format within specific information system or application software. And in health informatics, it's considered by some of on several types of EHR electronic health records, but general usage EMR and EHR are synonymous. So it will be not a critical mistake for you when you will use EHR instead of EMR, but it's important to understand that the previous difference, keep in mind the difference I spoken about already. And sometimes include even other like health information technology system which keep track of medical information, such as the practice management system which support electronic medical records. So means sometimes term EMR has been used as replacement of depiction or denoted of particular system like hospital, clinical information system, medical information system in general, and so on. It's also not a totally wrong, but actually would be better to avoid this and use proper term in proper circumstances. So, and right now it's time to define, at least provide some brief definition what is various kind of medical information system, and for sure we will start with HIS or CIS, Hospital Information System and Clinical Information System. It could be seen as comprehensive integrated information system designed to manage administrative, financial, and clinical aspects of hospital. And major aim for sure it's in compressed paper-based information processing as well as data processing with machines and automated approach. So again, dedicated to replace manual information processing with automated information processing. And here is actually again extension for previous chart about paper records. It's like aim replace that paper towers or like meters of bookshelf, dozens of meters of bookshelf in large hospitals, which keep paper medical records with their digital representation. So here is replace this with ability to access information at once with ability to access electronic medical records. So major aims of introduction of hospital clinical information system and its management of electronic medical records. But if we talk about the hospital information system, it's not only, and actually even we have more another aims than EMR because they are not the same. So about aims and benefits of EMR, I have already provided some brief intro. So now we move into deeply, a little bit touch the history of such system, which is born at later 1960s and have been introduced with a few largest hospitals in some world's information technology development centers, and then year by year spreading within different countries and regions. And here is we have like move here is depict some key points when we move from single monolithic application to rogue distributed system by the end of 20th century. And now we move into cloud system as service solution, which is from user viewpoint look like more, much more, again, look like monolithic solution. So we like create a circle around in term of visual representation or methodology for access system features. Despite that, we have absolutely different technical background behind this solution when we compare like 40, 50 years ago, monolithic application solution with modern cloud system, cloud-based system and CIS. And now about mention the difference between hospital and clinical information system. So again, it's not a large mistake to use it as replaceable terms, but would be fine again remember that clinical information system concentrate on patient-related and clinical state-related data. So clinical information system dedicated for management of electronic patient record, EMR, at first. And later, our hospital information system keep track on various administrative issues. So for sure, it's have also be used to manage electronic medical records, but primary goal is hospital automation. So it's have to deal with stuff, with a hospital repository like wards, equipment, schedule, and so on. And only after that, they are dedicated to manage electronic medical records. So here is, and what I might have to add that this distinguishing, it's not clear. Almost all CIS system have HIS features, and backward HIS every time provide EMR support. It's critically important. So it's more than, it's more related to how vendor, how developer make positioning of his system itself. Okay, so and if we will consider major tasks have to be supported by both clinical and hospital information system. So if we will speak about hospital information system, at first place will be administrative support, administrative logistic training of patient care intervention. Second place, it will be patient data collection, physician storage, retrieve, patient data examination, biosignals, images, everything that it's have to be possible to being stored within electronic medical records. Third question, decision. Diagnostic decision, simulation of inventory by using models, support of diagnostic and therapeutic decision making, and so on. Then monitoring, assessment and therapy, drug therapy, and reporting, assessment, and other features. So here is about hospital information system. If we want to turn our system into clinical information system, we have to move first point, administrative support, down and place it, for example, at least below decision or even maybe monitoring. If we rearrange aims of system in this way, rearrange tasks of system, so we turn when patient data collection, decision making, monitoring become primary goals, we will talk about that here is tasks for clinical information system. And practically, it's, for example, one of the possible interface, well-known Vista United States Information System. So, second classification, laboratory information system. After hospital information system, we turn into medical laboratory. And laboratory information system, or LIS, is class of software handling, receiving, processing, storing information generated by medical laboratory process. And major features of this, unlike clinical and hospital information system, its interface with instrument. So its ability to retrieve results of various observation measures directly from instruments and instantly store within internal storage or share with external systems by request. So in basic features, not only, but basic features listed at this particular slide when we talk about like patient check, order entry, specimen processing, results entry, reporting. Sometimes we can talk about keeping patient demographic if it could be important for laboratory processing or other supplementary information, or which could be retrieved from external systems like that's previously mentioned hospital information system. Features which is supported by or disciplines supported and covered by laboratory science could include multiply different specialities like hematology, chemistry, immunology, blood bank, surgical pathology, anatomical pathology, and so on. So we have multiply direction for application of laboratory information system. And another approach, it's implementation of offshore medical laboratories, like very popular practice in multiple countries, when they are not a department of hospital, but independent organization where patients being examined or by themselves or their samples obtained from patient in hospital sent to that offshore laboratory for processing. In Ukraine, a nice example, it's Eurolab, Cinevo, and a few others which have laboratories and processing centers like in almost in all regions of country, and results could be processed sometime, typically within days, but maybe at least one date typically required to obtain results, but in specific case maybe more. And here is given general workflow, how it can be look like from taking samples and through delivery to research facility, perform processing, entry and storage result into within internal storage, and send the result back to physician in paper form, or patient for sure, paper form or in digital form if it's possible. So personally for me, it's like conventional way to retrieve my results from Cinevo via to my email, and but it's much more difficult for my family doctor to get it, and I have bring that result. Like even last year, I have to bring it manually for her, but with latest changes in Ukraine healthcare now, we already established a sort of national health system, which new features being introduced each year, and even there we have some, as I know, some work in progress, which is related to integration of bridge to some laboratory information systems. Laboratory information management system. have to be distinguished from laboratory information system itself. So it's very similar things. Computer software used in laboratory for management samples, laboratory user instrument standards, and other laboratory functions such as invoicing and lots of, okay, it's complex automation of laboratory, but in this case, and the difference between LIMS and LIS, that's laboratory information management system, generally touched the environment, research and commercial analysis, and pharmaceutical, petrochemical, and so on. And LIS targeted towards the clinical market, hospital and offshore clinical labs, which I mentioned, like CINEO also. So would be fine to keep this in mind, that even we have this specific difference in terminology, specific difference in as we're talking about features, that they are very closely, very similar, but we have significant difference in marketing target. And it's how it could be look like some kind of starting screen of a live FIOS system. Radiology information system, or RIS. Used typically in radiology department to store, manipulate and describe patient radiologic data and imaginary. So in some specific case, it's even very similar to picture human communication system, which already introduced at third lecture at the end of previous semester. But in fact, there is some kind of difference for the system, and even I will remember PACS soon. So features very similar to that listed in laboratory information system, like patient registration, scanning, results entry, or directly obtained from direct acquisition from imaging equipment, and then the result delivery in various way, mailing, electronic messages to various hospital information system, clinical information system, and as well. Then multiply structures, flowcharts could be seen at this slide when we have different vendors approach, how it can be look like. In logical statement, for sure, it's almost the same if you will speak about usage of PACS and building the PACS, but like in this case, as you can see, the specific solution from Zair's company, they have, if you will look into middle row at center of this image, you will see that we have at least two solutions. One represented and colored like RIS, radiology information system, and second in row colored PACS, picture human communication system. So again, dependent to vendor viewpoint, dependent to vision of vendor's vision of architecture development, we can talk about even combination of both this system within some integrated solution. And very quickly, I recap question from third lecture, picture human communication system, computer network, dedicated to storage, retrieval, distribution, and presentation of image. So, which could be stored in various formats, but major feature of PACS, its ability to DAO and store of images, which is encoded in DCOM format, digital imaging communication in medicine. Actually, RIS, radiology information system, also must be capable to processing of images in this format. So here is example how classical PACS could look like, which is represent computer tomography operation system. In fact, it's operation system. So AIM, it's replacement of hard copy based means of managing medical images like film archives, and also expand possibility of such conventional system by providing capabilities of site viewing, reporting, like for distance education, telemedical usage, and so on, and also sharing within and delivering the electronic format to remote sites, to remotely connected system like medical, various hospital and clinical information system, in order to images being included into patients' electronic medical records in those systems. So here is actually, in fact, what I made emphasis, its ability to have interface with existing hospital information system like CIS and radiology information system. And here is like, again, as I remember, I shown this chart on third lecture. So here is similarity and difference between PACS and RIS. So RIS include various features which is dedicated to perform management for personnel inventory, accounting, management for radiology department, when PACS concentrated on only image processing. In fact, it's even broader interaction possible, and it's even will be much better if we will have few systems integrated and working together. It means when multiply system interconnected, and we have ability to perform some action in even starting like left side, and this picture from by using automation system perform initial registration even during within ambulance, within first aid department, and then provide some initial recording of data within hospitalization system, turn into radiology information systems, then, if necessary, provide patient observation, retrieve images with capabilities of RIS and PACS, and sharing result with all staff which is required, access for this data, and creating some backup copies, even on paper, films, and so on. Practically, when most of physicians, especially chief executives of hospitals, spoken about hospital information systems, they are interested into integrated solution which would cover all possible aspects of hospital activities, which allow to perform like total automation of all departments, and as you can see at the bottom part of slides, so conventional expected HIS solution would be fine to cover everything from electronic medical records to picture hearing system, and up to various questions related to automation of administrative issue and administrative processes. So in other more detailed representation of integrated medical information system or integrated hospital information system given on the following slide, which have included again here listed same part of components from previous slide, but what is interesting here is we have again additional block labeled as MIS, but in this case it means not medical information system. In this case it means management information system. So management information system have to be part of integrated hospital information system. And here is also important point. And when we talk about integrated information system, would be fine to denote types of integration. And here is 3 of it. So first of all, it's in most conventional, it's data integration. It's ability of one application to access data which is created by another application, typically possible through sharing database access, but also it means that each one application have to implement a model of database which is created by another application. But it's earliest version of access of data integration, of integration of information between and sharing information between various applications. Another approach, it's presentation integration, when there is data from various applications presented to user in an accurate and consistent way. Fine example, it's like Microsoft Office solution when they have unified interface, but actually they are not compatible on data level, so it's not possible so easy open like Word documents with Excel and backward, despite possible making certain of one object type inside other and skip link to original document and original application, but it's not full integration. It's integration, but it's not maybe comfortable way of integration. And one of the, if you talk about simple classification, the third way, it's functional integration. That's function of different applications are able to qualify the user within one user environment. And excellent example, it's usage of a browser to access various web systems. And especially, for example, when we talk about Google Apps for education, or Office 365 solution, which in fact provide both functional as well as presentation and as well as data integration, because we talk about usage of various applications which exchange digital messages in background in order to provide and fulfill user requirements for access data and perform specific operation. So here is functional integration. And if we talk about implementation of medical information system, it's important to mention important to mention about one critical features, that it's interoperability of or ability of different information technology system and software application communicate, exchange data creatively, consistently. So if you talk about practical implementation of previously mentioned one of three levels of integration, we will be talking about interoperability of such a system. In fact, it's very hard question in case if we talk about a different system developed by different vendors, and we want to establish communication between such system, and even it's required some time of a kind of regulation provided by governments. And here is at the bottom of the slide give an example for United States, which have to relatively recently, like 16 years ago, provide some special government rules to enforce and to force vendors to exchange information between their system based on National Health Information Network. So here is specific for United States. It's have to important that it's not, in fact, it's not a fast moment when interoperability in medical information system has to be introduced. Technical capabilities was available even dozen years before it, and I have spoken about this on second lecture, including classification, about few of those moments. But to fulfill to force vendors. It was necessary to introduction of kind of governmental rules which provide background and describe legal question about how this interoperability works. So here is the following slides represent major 4 levels of different categories of data structuring. Healthcare data exchange can take place. And for sure, most promising its last third and fourth level when we talk about almost machine organizable or interpretable data, which can be automatically translated and transmitted between various information systems via conventional computer networks and processed by each system. So third and fourth level, because third level include here 7 standard compatible messages and indexes. So at least they have like digitized metadata, despite that entire documents could be something like machine transportable representation, like even scanned documents or so. But they have at least added HL7 compatible metadata. And here is if we talk about a full list of various, even not full, but like general list of most common standards which is involved and dedicated for various type of data exchanging and interchanging. So here is the slides represent those standards. And as you can see again, a few times I already mentioned HL7, DCOM, but also label X12 and other standard or their combination, which is necessary to connect or exchange data with for specific purpose or with a specific agency or organization. Here is like brief the notes about difference of the standards. What is most important from all this set? It's X12, HL7 and DCOM. In fact, HL7 become already components of X12 already become components of HL7, and we have even extension, latest extension of HL7 is here interface, which is introduced 4 years ago already. Again, more information you can find in lecture on coding classification. Finally, about this part of lecture, how it can look like from patients, from physician side. Again, it would be fine if it look like transparently, if it's look like how you deal with Google applications in our university, when you just authorize yourself within your email account in Gmail service and become granted access to various type of services on the Google Suite for Education, like docs, spreadsheets, and much more. So in similar way, here is we have conventional workflow, how patient want to visit physician office or hospital, and so here we have to be questioned by if it's not an urgent visit, if it's not deployed by ambulance. So here is will be questioned, registered within hospital information system. probably directed to laboratory for specific examination, and his result will be stored within laboratory information system, and registration have to be shared with LIMS. Then typically nursing provides some assessment and decision and about priority of access to general practitioner or other physician, if it's we talk about hospital with multiple physicians, and which also all those physicians have to be able to share and access information from initial information from hospital information system, laboratory examination, or any other records which done, or have to provide their own notes made, for example, some examination by using medical imaging equipment and so on. So all this system or have to be components of integrated hospital information system, or have to provide data transparent data exchanging, and even up to creating bills, reporting to insurance company, etc., etc. So ideal cases if it's possible. Practically, okay, available such solution, or available way to implement this even by using free and open source solution, but then some set of efforts required. So that's all about previous part, and now I move into practical implementation. So what is lie behind any information system, no matter if you talk about medical information system or other kind of information system, and here will be data storage or database. So we have to define what is database itself, and then major part of lectures will be dedicated to relational database, like most common used in various practical information system. And finally, I will try to provide brief intro about what is NoSQL databases. Okay, definition, types, and models of database. So again, just check beginning of previous lecture, what is information system? System person that acts activities that process data information in organization, including manual and automation-based process. And during this lecture, and we will consider only computer-based information system, which is information technology components of information system, and a field for study for information technologies. So if we talk about any integrated hospital information system, no matter what we kind of, so our input is all kind of clinical documentation, and text information have to be stored within electronic medical records, various images, results of laboratory examination, and so on. We need some sort of storage to keep this. We need some kind of like data warehouse, also how we can implement it, typically in form of database. And if we will like consider flowchart of some kind of hospital information system, it's every time will be contain one or few icons which represent a database, because especially if we talk about integrated hospital information system, it's very often situation when we will have more than one database within information system. And if we turn back to that picture I already shown for you, here is at least two database icons were present there in those charts. So database, it's every time key points of any information system. How we can define database? Lots of various definition you can find under different textbook documents and so on. Here is just pair, which is actually also relatively simple and old. In brief, we can see a database as computerized record-keeping system, and more detailed, it's system which involve data, hardware that physically store data, and software that utilize hardware file system in order to store data and provide standardized method for retrieval or changing the data, and finally users who turn data into information. So same as about information system, when we talk about database, we can't distinguish database from users who utilize it, because even if modern database sometimes create automatic system and filled by automatic system and even explored and used by various software solution, its final goal is fulfill demands of humans. So at end of chain of information processing, every time will be user who needs some sort of data which is stored in some specific database somewhere. So at left side we can see various, at least two different information system. Above especially it's OpenEMR medical information system, and practically at right side that we have like block diagram, how it can be represented and where is the database will be placed in this case. So we have user who deal with some client application, no matter it's desktop or web application, and that application has been used to visualization data, to provide user interface to enter to data entry, and access or modify data which is already stored in storage, and the storage is a database. And at right bottom corner shown even a little bit more detailed point, which also include not only database application, so client application, but also RDBMS or database management system, which turn like high-level request into elementary atomic operation on data structures which is stored on some specific physical layer. No matter is it we talk about one computer or something like Google's data center, which consists hundreds and thousands of servers, physical servers, and such numbers of hard drives and so on. About classification of the database. First of all, classification by types. There is only very simple, only two types we have: analytic or OLAP database, on analytical processing. So static read-only database which store archive historical data and used for various types of analysis. And operational database or OLTP, online transaction processing, which is used to manage identical bits of data. So every time we talk about usage of electronic medical records, we are talking about an implementation of host management system. Every time we talk about OLTP database, if we can edit, update, insert, so it's OLTP. OLAP we can only read. But even in case of OLTP, if we refer to some historical information, which is already after some period, information could be marked as read-only and prohibited to being changed, updated. So some features of OLAP database could be found even under OLTP database. Again, distinguish not very strong, not very strict. Regarding the database model, we can identify 5 conventional models, which is only like last pair, it's practically has been in use. Flat file, very old approach, deprecate, but anyway, sometimes even could be seen even now. It's like we can use shared CSV spreadsheet files to access data. So spreadsheet could work as database. It's very inefficient way, but it's possible. Then hierarchicals, when we represent some child-parent relationship, A network database which allow for us more advanced horizontal links between it's like advanced version of hierarchical database, which allow various horizontal links, or where a child could have multiply parents and so on. A very effective model, but very hard to be implemented. A relational model represents data in form of two-dimensional tables. So it's like when instead of single spreadsheet, we use multiply spreadsheet, link it together. An object-oriented database, it's like extension of relational database when we have extra, actually here is we have extra level. Relational databases represent for us data in form of tables, where object-oriented represent list of attributes and their values. So here is like shown general view how it's things that models could look like, and a little bit more details about it. So hierarchical. It can be visualized down tree of data, and this tree single table acts as a root and database from which other tables branch out. So user can add records problems. Can add records to child table until has already been incorporated into the parent table, and redundancy would occur because hierarchical database handle one-to-many relationship well, but not many-to-many. About this type of relationship, I will spoken later. As you can see here is we have at the bottom we have problem of redundancy when we want to assign patient to department, or at least for temporary, for some case. Here is we will need duplicate information about this patient. So in network model similar to hierarchical, but actually hierarchical, it's simplified subset of network model. Major features that in network model multiply parents for one child allowed, so many-to-many relationships supported well, but it's very difficult to track concurrency in relationship connection, and updates of each node through their parent to child relationship. So here is given example. It's a very simple case, but practically we will have something like much more complicated. For instance, it's like visualization of like friends connection to their friends, friends to friends to friends in social networks. So it's exact fine example of what is network database structure. So now moving to the relational database, which was born in about 50 years ago as scientific project by Dr. Ivkod, and still remains one of the most popular and practically used, widely used within like most of commercial application. Major features, it's representation data in form of two-dimensional table. Each table represents real world object, so we have strict relationship between table and some entities. That's information about these entities become represented and stored in this table. And also we have conception of relationship between table which is introduced by values of specific attributes which have specific purpose and used only for relationship. Now to tell more about development of relational database, actually I will try to pass through steps of and notation for use in relational database development. Then we provide some more detailed overview of relational model. I try to present related structure terminology, major features, properties of relational table, case, and even spoke about normalization and practical usage of RDBMS, if it will be enough time for this. In fact, it will be your practical task for topics 14, 15, and partially 16. So, actually, steps for database development, which is very similar to the same for any application software. So we have to analyze requirements, create plan and define our systems, then create this initial design. First of all, it's logical representation of our data structures, then decide about their physical implementation, and practically implement with usage of specific solution. If we will work more detailed, so at the bottom right side, you can see like we have to still identify requirements and collection analysis data, then perform data modeling, database design, implement it, and run into production. What is important to know that during collection of requirements analysis, we have to summarize various external representation of data. It's like noted at the bottom at left side, when each one user who will work, various user of various specialities who will deal with database, for example, physicians of different specialities, have own requirements, have own vision about how data have to be represented for them. And even we talk about physician, but also some administrative staff have to work with information system. So they will have completely different vision, which kind of information do they need and how they have to manage it. So here is called external representation of our database. And then based on this, dedicated person, organization, which is responsible to design, develop database, have to create some logical representation, logical model of database, and then make decision about practical implementation. One of approach to visualize database structure is entity relationship diagram. For example, like this one, which represents some parts of a hospital management system. It's even not all questions. It's very, very small, like simple part, which provide in rectangles, blue rectangles, its various objects, violent ellipses, its attributes or properties of these objects. And in rectangles, triangles, we have some operation have to be done or have to be managed by these objects. And in double market with rectangles with double borders, we have like collapsed object which can have to be also extended and which will have much more various details. So if we back to definition of relational models, as I already said, that it's represent data in form of two-dimensional tables. So organization of data into related tables known as logical view of database. Here is practically, again, I sign, it's only logical view. Internal view will be depend about specific application software which have to be decided to use to implement database, this database, and will depend about like scale of database, and even have to be updated through database life cycle, so we can start small research project at own computer and create it with some sort of personal database management software. And then if it will be, you will be lucky, and your project will be interested, like serious organization will be interested in your project, it could be scaled or transformed into another internal representation with keeping and maintain the same logical view. Actually, your task, for example, topic 14 and then 16, it will be deal with logical view. Topic 14 implemented, topic 16 create your own. Regarding terminology, actually, few of things have to be there is lots of terminologies under relational database usage, but I will mention only like 3 major. No, database, every time we use this term database, but if we will speak about tables, column, and rows, which is in fact term most time used in spreadsheet application, already known for you Excel. In case if you will use database, relational database terminology, so table we use the same term, but instead of column have to be used term field, and instead of row, records. In case of logical representation, in case of you said relational database, relational logic, which is in fact separate branch of mathematics, equivalent table is relation, attention, not relationship. It's interconnection between tables. So table, it's relation. Field, attribute. Field or column, it's attribute. And row or record, it's tuple. So all, at least this 3-4 term have to be remembered, and try don't mix them, don't forget about what do they mean. So what is a relational table? It's we can see it as flat file. We can see logically as flat file, which composed of a set of named columns and arbitrary neighbors of unnamed rows. So data value is stored intersection of row and column, and it's in fact attribute value of specific attribute. And columns of tables contain information about the tables. So row of table represent occurrence of thing represented by tables. So columns or attribute represent one specific feature of entity which are simulated in table. In table, we store information about specific real world entity. For example, have to be patient for table, have to be table for storing patient information, or department information, or about something like students' marks, for example, and so on. In this case, separate columns represent single one attribute or features of this entity. For example, patient name, or surname, or birthday, or in case of department name, or department address, or in case of students' marks, it's have to be like date of when the students grade, or a reference about who obtains this mark, reference to some identification of patient, some class topic, and actual value of mark. So here all these things, it's separate grades, separate columns. Then Single row or records represent occurrence of things, represent information about particular instance of object, like row or record in patient table represent information about single one particular patient. Row on the department table will be represent information or whole information about this particular department. Row in grades table will be represent all grades or information about this one grade for this one particular grade of mark. Properties of relational tables. Values atomic, column values have the same kind. Each row is unique. Sequence of columns insignificant. Sequence of row insignificance. Each column must have a unique name. Okay, pass through each of this quickly. So first of all, columns in the relational table not repeating groups of arrays, such tables that it's demand of so-called fast normal form under normalization. So at intersection of rows and columns must be single value. It have to be like number, it have to be string of text, but it must be one value, not combination of multiply. No matter even if it could be picture, it could be even picture with size or video with size of gigabytes, but a single item, single thing. Columns value are of the same kind. So here is major difference of the database relational table to spreadsheet. Under one columns in spreadsheet you can put any value you want. And Excel or any other spreadsheet software will manage with this. Under in relational database, if you define that this column dedicated to use to being used as to store patient last name, so the only text value of patient last name must be stored in this column, nothing other, and so on. Each row is unique. That property ensures that no two rows in the relational table are identical. There is at least one column or at least columns that's value of this unique identity each row in table. So that means impossible to have two exact rows with same patient information. Even if it somehow happens, must be present specific column, specific attribute which will provide something unique. No matter is it mistake or maybe not mistake. For example, definitely probably each one patient must be unique, but sometimes happens that if we have limited information like first name, last name, birthday, may happen that we will find a few person with the same exact information. It's not a rare case. So we must be able to distinguish them to ensure that they are two different persons or some kind of error already happened. But in other situation, very often could happen that, for example, different students at the same class at the same time got the same mark. Well, it's ordinary things for right now. In this case, it's not a mistake. We have the same value, just they have to be related to different persons. So here is that things, relationship, have to give for us information about ensure that each row will be unique. Sequence of columns and row insignificant. Not in spreadsheet, especially if you use formulas here. But in the database, its features, no matter how we rearrange columns and rows. We access by column data by unique column name, which is unique, and we have to access row data by using that unique identifier of each row. And for us, no important where is our actual row each time. At the end, at the beginning of the data set, somewhere in the middle, no matter. I already mentioned that each column should have a unique name. Okay. Then now we move into relationship terminology and how to link information about from one object to another. And it's implemented through key relationship mechanism. First of all, it's necessary to introduce that special attributes for each object, that special columns for each table, which will act as key fields. At least two key fields available, primary and foreign key. So primary, it's columnar columns in table whose value it's unique identificate each row. That things mentioned just a minute ago. Each row must be unique, and we must have ability to identify and distinguish this one row from any another. And it's have to be done via primary key value. It could be combination of already existing data, or it's have to be very common practice when extra column have to be added, synthetic, which is not visible, very often not visible for user, but provide information for a relational database system itself. Sometimes it's called like IDs, various type of IDs. So this value plays a role only inside this database. In some cases, it's have something like similar to like passport number also, but in fact, it's a very bad idea to use passport number as primary key, because, for example, not everybody have passport. Like newborn doesn't have passport, or sometimes some students doesn't have passport, or maybe different countries have different formats of passport names and numbers, and even have faced duplicates of values within different countries and so on. So passport numbers, it's a good example of primary key, but must not be used as primary key, never. And foreign key columns, whose value are the same as primary key or another table. So difference between primary foreign key. Primary key value must never repeat within one object. So if we have add primary key to patient table, it every time must be unique and never repeat, even if like we have to remove patient record, do it in disease. So already used value will be never repeated. But if you want to refer all patient examinations or all students' marks, we can repeat his value of primary key within foreign key to establish those relationship between patient table and like examination or students' grades table on the relational table. And here is example how we can comprise that thing's primary key. And here is labeled now like ID and added to that informational field available in our relational table. So we have like at the right side, we have 4 fields which is important for user, informational fields like red number, first name, last name, mail, but we have extra ID field which has been used as primary key and have value which is never repeated. And in fact, example how we can join patient to department, or physician to department, or teacher to department, in this case a teacher. So here is we have a list of teachers, departments, and as you can see, department, in this case not department ID but department code label has been used, repeated for each patient for each teacher who assigned to this department. And in this case, on the department table, department code play role of primary key and the teachers assignments on teachers table, department code play role of a foreign key. So now a few times I repeat terms about relationship between various objects. Under objects, I mean then in this case a logical term entity, something from real world physical object or some term or something. And we have three major relationship type. One-to-one, when at most one instance of entity B A is stated with one instance of entity B. Not very often used, but sometimes helpful when we want to provide some extra details, which is maybe not like too hard to grab to be kept within major description, but important and have to be stored as well. So like extra details about products or extra information about student or patient, like when we talk about main information, maybe it's enough like first name, last name, passport number, and on the student's details we could keep information about parents, habits, photo, and lots of other things. One-to-many relationships, when one of instance of entity A, which are 0, 1, or many instances entity B, but one instance of entity B, it's only one instance of entity A. Actually, it's keystone of relational database. Major type of relationship being used practically. When, for example, we have conventional example assignment teachers to classes, when we have a list of teachers and which spend multiply classes. For example, today it's third class for me. So on the teacher I have, for sure we have such an automation system in our university called also, and here is I have created single record for me as a teacher, and I have multiply records for classes I offer for, I am assigned to be provide service for students. So at least 3 today, but much more every day. So, and here is we have example how it could work. When teacher ID will be repeated, teacher ID's value, my value, assigned to me, will be repeated within each classes I talked for you. In this case, similar situation we talk about. So you can consider if you will participate in this lecture or previous classes, you can replace teacher side with student side, and it will be work exactly the same which students attend those classes. And third type, many-to-many relationship, when we have like, for instance, one instance of entity A, there is 0, 1 main instance of entity B, and for one instance entity B, there is 0, 1 main instance entity A. It's like a general relationship between all teachers and all classes in university. Not only dedicated for me, but all classes which is scheduled, arranged, and have to be done in university today. For example, or all students and all teachers and so on. Practically, there is no direct implementation of it, other than split into few pairs of one-to-many relationship. So here is given a simplest kind of solution. When we split many-to-many relationship into two one-to-many. at left and right side, like we have students which are enrolled to take specific classes at specific time with specific teacher and so on. So even this solution, it's correct. And if you want to add the teachers here, we have to add the force table and link it to enrollments, not to classes, but to enrollments. No, sorry, to classes right now in this condition. In reality, may happen that it will be need multiply such stages. Will be not enough to split one many-to-many into pair of one-to-many. May happens we'll need much more such stages. And a real database system could contain hundreds of tables and solutions. Another example, relationship between ordering products. So if you order something every time in like online shop, it will be every time follow in this way. Like what is ordered in which quantity, by which user, and so on. So major features every time, it's availability of join table which contain multiply foreign keys. If conventional, when in case of so how many linked table we have, typically such number of foreign keys have to be, and it may happen that its join table will have dozens of foreign keys. It's no more keys. Primary key every time will be one, must be one, but foreign we could have multiply. Okay. Finally, about development stage of database, some extra rules like data integrity have to be considered when we determine state that value of the primary key can be never be null value or never will be repeated, or that its principles which condition must be passed in order to system will be able to allow for user to change some specific value, how we have to deal with the relationship in this case if you want to delete like student's mark or some patient records, what we have to do with all this other information which is related to, and so on. Same way normalization. Now I'm back into top level. After initial like creating draft of database design, very often we need to perform some kind of normalization to simplify structure, to make it more efficient, and so on. Like about 5 normal forms available, and here is example how we can move from fast at least to about 3rd normal form. Because first it's decomposition, it's reduction back to origin. So here is we'll have like our values atomic. So this given table already in fast normal form, but we have lots of redundancy under S and P column. So we can split into normal form when every non-key column it's fully dependent upon primary key, and here is we use with red, here is select primary key, and green, so green area, it's green circle, well, it's a foreign key. So we have separate like status from parts in this case, and with 3rd normal forward, so it's in this case, non-key columns don't necessarily depend upon primary key. In other words, all non-key attributes are functionally depend only upon primary key. So we separate city status, supplier city parts, and every time we can access parts by value of obtained through city and supplier status. And here is will be how it can be look like. So to store our information, we turn one table into a 3. Okay, how it could be represented logically with formal logical forms? That's a question from topic 10. So here is algebra logic. And here is example how it can look like in case if you want to create at least unity of two table. So for sure it's not a question will be for you, because we will work maximally with database management system or special software which help us to manage database and provide some kind of graphical interface for database development. Practically, it's dedicated to use by special staff, database administrator, who have skills how to manage database. And here is the bottom of this chart. You can see how database will serve data for various applications, want to access this data from different type of relational or even not relational database. So it may happen that one RDBMS capable to manage various type of data like relational, object-oriented, hierarchical. No, in this case, for sure, I'm talking about enterprise level solution. And here is like what is behind, in fact, database data integration itself. So if you talk about data integration itself, it has to be covered with database management system. And also such system could provide interface which allow for us to visually create entity relationship diagram and create database by drawing our diagram. So we draw it and necessary on disk structure will be created in response of our drawing. And actually special programming language available for this, or SQL, structured query programming language, which allow for us, which have two purposes. In fact, it's allow for us to manage data in databases, but it also allow for us to manage database itself. So here is example how we can represent some, how we can retrieve information from database according to various criteria. And by linking multiply tables, actually it will be your task under topic 15. Just you will no need to do it in SQL. You will do it in visual way by using visual tool offered by RDBMS Microsoft Access. Okay. Actually, we are run out of time, so third question about NoSQL database look like I no longer time for you to show it. And before we will left, just final example, it's like OpenEMR medical information system. When I can look in it, and here is general practice clinical information system dedicated to create management, to managing electronic medical records for patients. So here is we have patient record, and what is behind this information system? So for sure it's database, and here is another web information system which dedicated to manage of MySQL database systems. And here is what is in fact this. So we have like hundreds of tables, 244 tables composed of OpenEMR database. About the same compose Moodle, 400, about almost 500 compose universities ASU system. So behind this, we have database with 500 of tables. And I don't know if it will be possible to draw design of OpenEMR right now. No. Okay, can't, too many tables. Too many tables, we have issues. So we can, no, for me it's actually even no necessary to deal on this level. So actually, in fact, that is how things I want to present. Practically, you will work with this application. Microsoft Access, all necessary materials provided on the Moodle. So thank you for your attention and goodbye.